All right, hey guys, we are going to talk about some basic probability today, just starting with some basic rules and Venn diagrams in probability. So we're going to take this situation where there are 96 seniors at a certain school, and in a particular year, we're going to say that 26 are in stats, 28 are in calc, and then there are 7 that are in both stats and calc. So we're going to use this situation to run through some basic rules and Venn diagrams today. Okay, so these blank notes are posted on the class Google Calendar if you wanted to print them out at home and watch this video. You can do that, or just kind of take some notes as you go, and then of course submit your final note or a picture of your notes to Canvas for some free points. All right. Okay. So we're first going to start with some vocabulary. The first vocabulary word is event. And we're going to be talking about events a lot in probability, and you can see that the definition is a particular outcome or a group of possible outcomes from a sample space. Now, we talked about sample spaces and outcomes in class today after your quiz, so hopefully you are good on that. We will denote all events with capital letters. So let's start with this event. Let's let capital S be a senior that's enrolled in AP Stats. That's what we're going to define as an event. So if we randomly select a senior out of these 96 seniors at school, what's the probability that the senior is enrolled in AP Stats? Now, we've learned from probability in the past that we always put the total amount in the event over the total amount in the sample space. So in this case, there are 96 total seniors that we're randomly selecting from, and of those, 26 are in AP Stats. So our probability would be 26 over 96, and we can always change that into a percentage, or we can leave it as a fraction. Totally up to you guys. For today, I'm going to use a lot of fractions, but if you wanted to, we can change that to 0.27, or of course, we can say that that's 27%. Any of these answers are fine, and you won't get counted wrong, so it's totally up for preference. One thing I wanted to teach you, though, is that usually we don't like to have naked numbers in stats, and right now these are naked numbers. That means that you only had a single number answer for a question, and we usually try not to do that in stats. I got to get you in a good habit. So I want to show you probability notation, and probability notation is defined with a capital P, and then you put the event in parentheses beside the capital P. So basically in stats language, this says the probability of event S is equal to 26 over 96. And we defined S earlier as a senior being enrolled in AP Stats. Okay, so practice having that good probability notation there. Okay. Now, the next question that we have on here says, what's the probability that a randomly selected senior out of these 96 seniors is not in AP Stats? Okay, so we have a new event. This time the senior is not in AP Stats. And let's just kind of talk about first the answer to this. Of course, there are 96 students, and if 26 of them are in AP Stats, we know that 70 would be not in AP Stats. We just subtract 26 from 96. So 70 students, 70 seniors are not enrolled in AP Stats. They're enrolled in something else. So notice that this is just kind of like the opposite of the problem we just did up here. So 70 out of 96 would be 73%, right? So notice that this is just 1 minus the probability that they are in stats. Okay, so for instance, 1 minus 0.27 is 0.73, or 73%. Okay. Now, since it's just the opposite, we don't have to define a new letter. We actually have a special symbol for not, right? Like not an event. And that symbol is called the complement, and you can see that definition down here. The complement is all outcomes in a sample space that are not in a particular event. And our probability notation for that looks like this. So it's like an exponent of a C. So if you see an exponent of a C, that means not enrolled in stats. Or not, it's like the opposite of that event. So the complement rule down here is just what I wrote up here. The probability of not an event is just 100% minus the probability of that occurring, or 1 minus the probability of that occurring. Now, I will say that when studying complements in college, you will see a lot of other notations besides just the exponent of C, although in AP Stats they use that exponent of C. But just if you decide to study probability later in college, you may see it with a bar over it. That means complement. But as you'll learn soon, that kind of gets confusing with a mean. And then sometimes the complement is given as a little prime, which of those of you who have had calculus can sometimes be confused with a derivative. And then a squiggle sometimes also denotes a complement, and that can sometimes be confused with approximately. So I don't want you to think that I taught you wrong if you see these other symbols later on in life, but the one that the AP uses is that little exponent of a C. Okay? Again, just kind of running through some of these rules. Let's talk about now another important vocabulary word: disjoint or mutually exclusive events. So sometimes they call it disjoint and sometimes they call it mutually exclusive. But basically, disjoint events are ones that have no outcomes in common. Okay? So there's no way that there can be something in both. So, for instance, if I let the event C be that a senior is enrolled in AP Count or AP Calc, C and S, the fact that that S is a student is in AP Stats, C is in Calc, they're not disjoint events because there are some that are in both. So there are many cases or things that you can think of as far as disjoint events. So I could let one event being left-handed and one event being right-handed. And I know there maybe are some that are ambidextrous, but let's pretend maybe that's a bad example. But usually they are disjoint. You're either left-handed or right-handed. So that would be disjoint events. Earlier today I asked second period if they were for plan A, plan B, or plan C. Well, those are disjoint events because you can't actually be in plan A and plan C, or you have to vote for one or the other, right? So disjoint events, there's nothing in common that they don't overlap at all, whereas non-disjoint events do overlap and have outcomes in common. So getting into some Venn diagrams. Venn diagrams are a tool to help you answer some probability questions. And and it won't be the only tool that we have in our toolbox for probability, but it's one that we can use. So we're going to kind of shift over to that. By the way, Venn diagrams for disjoint events are kind of boring. Since there are no overlap, let's say that that's event A and a disjoint event B. Notice that there are no overlap between those two, so they must be disjoint events. Whereas if they were non-disjoint events or non-mutually exclusive events, their Venn diagrams would overlap. Okay, so this part right here would be the overlap right there of event A and event B. Okay, so obviously Venn diagrams for disjoint events, not very interesting. Non-disjoint events, totally interesting. So that's what we're going to look at now. So let's go back to the events S and C, and let's set up a Venn diagram for that, okay? So let's start with this being our stats students. So event S, I'm just going to leave it at S. And let's let this be our calc students. Okay? So one important thing I want you to note when you're setting up a Venn diagram is that we must always label the overlap first. Okay, so as far as the stats and calc example, there were 7 students that were in both. So our probability that if I draw a person and that person's in both stats and calc would be 7 out of our total 96. So that number isn't going to go in our overlap. Now, if I remember, the probability of S was 26 out of 96. But I'm actually not going to write 26 out of 96 right here in that S. Okay? The reason is because technically 7 of those are already counted for in this part right here. And notice that that part right there is a part of the circle for S. So 7 of those are already counted for. So that's why I want you to do the overlap first, because what you're going to do is actually subtract out that 7 from the 26. Okay, so that 19 out of 96 represents this part right here, which is the being in stats and not calculus. So there's actually 19 people that are just in stats. And we've got to do the same for calculus. Remember above that there are 28 enrolled in calculus. Okay, but I'm not going to write 28 over 96 here. I'm going to subtract out that 7 that I've already accounted for that are in calculus and stats. So I'm going to subtract that out and actually put a 21 here. Okay. So this 21 represents just in calculus, not in anything else, just in calculus, 21 out of 96. Now I'm not done. If you notice that if you add up 19 out of 96, 7 out of 96, and 21 out of 96, it doesn't equal 100%. Okay? Let me think about the math here. It actually equals 47. Yeah, 47 out of 96. So that means there's 49 other students to be accounted for out of the 96. And that's the 49 students that are taking neither stats nor calculus. So they're going to go out here, the 49 out of 96. They're going to come out here to represent the rest. So now you see that if I add the 49 out of 96, 21 out of 96, 7 out of 96, and 19 out of 96, that's going to add up to 100%, all within that square around the Venn diagram, and that represents our sample space. Okay? So that's how we set up a Venn diagram. We always start with the overlap and then subtract it out, that overlap out of the probability of S and C to put in the circles, and then everything that's left over goes on the outside. Now coming down here, I'm going to do some examples of using probability notation and where it particularly is in the Venn diagram, okay? So the first question says, find the probability that a randomly selected senior is enrolled in both courses. Remember, that is right here, the overlap. That was our 7 out of 96, or whatever decimal that is. I'm just going to leave it. So the region in the Venn diagram is that overlap. So I'm just going to draw that overlap right there, section, the middle. Now, the probability notation for this looks like this. This is the probability of enrolled in stats and calculus. So that symbol, you've probably seen it before, maybe with domain and range and interval notation. That technically is called, or we use it for AND problems. And technically its math name is an intersection. Oops. So it's like, where do they intersect? Okay, so that upside down U goes for AND. Okay, so that's the probability notation for that middle overlap. All right, next one. A randomly selected senior is enrolled in AP Calculus only. That means no stats, okay? So we know that that is this section. Let me change colors here. That's this section right here, calculus only, right? Calculus only. So that was 21 out of 96. So that is like this part of the Venn diagram, kind of like a crescent moon. Okay, now I can't use just the probability of C for this, because the probability of C would be that original 28 out of 96. Okay, everybody that's in calculus and also in stats, right? So I can't use just probability of C. I actually have to say the probability of calculus and not statistics. That's what that says. So just calculus, not statistics. You have to tell them to take out that overlap. Next, what's the probability that a randomly selected senior is enrolled in stats only? Right? Stats only. So that's the other side of our Venn diagram, the other crescent side. Sorry, that's rough. Okay. So this part right up here, only stats, no calc whatsoever. Okay, almost like a little Pac-Man or something. So of course that probability is 19 out of 96. We found that earlier. And the way we would write that, we would say the probability that they're in stats and not in calc. Okay, next problem. What's the probability that a randomly selected senior is enrolled in AP Stats or AP Calculus? Okay, now it's something to note is that one of those tricky things about probability is when they use this word or, they're saying S or C, and then there's an understood or both. Okay, so anytime you see an or problem, you need to go ahead in your mind and tack on or both. Okay. So the region in the Venn diagram, this is actually looking at stats. So stats, calculus, or both. So we're actually looking at all three parts of the Venn diagram added up. Okay, so going back up here, that would be stats 19 out of 96, calculus 21 out of 96, and then both. That would be a total of 47 out of 96. Okay, and the probability notation for that is going to be not using the and symbol, since this is not an and problem. We're actually going to use the or symbol, which is stats or calc. So that U, it's not a U. Don't put a little thing right there. That's wrong. Like that. We use that symbol for or problems, and it's called the union. Okay, the fancy math name is called the union. Okay, so kind of going off of the addition you see that down there, it says the addition principle. Going off of the or problem, there is something called the addition principle. Notice that to get this 47 out of 96, I told you guys it's the probability of stats, the probability of calc, and then the probability of both. Now, you may have thought in your head, okay, that was, the probability of stats or calculus, probability of stats, and then add to it the probability of calc, and then add to it the probability of both. Why do I keep wanting to write A? Sorry. Stats and calc. But this technically is not what we did. We technically did the probability of stats, this right here, the probability of calc, this right here, and then the probability of the intersection, this right here. What this says right here is, or down here, the addition principle that we're talking about, that says you take the probability of stats, which would be this whole circle right here, including the 7 out of 96, okay, which is a total of, what was that, 26 out of 96, okay? And then the probability of calc, which would be the whole entire 28 out of 96. So the problem with what we just did, if I did the probability of stats, the whole thing, and the probability of calc, the whole thing, I counted that overlap twice. So actually, if I changed this to subtract out that overlap, that 7 out of 96, guess what I get? 47 out of 96, just like right here. Okay, so basically what I have just shown you is that you can find the answer to an OR problem in two ways. Okay, so an OR problem can be found in two ways. Way number one is to do just the crescent, left crescent, the middle, and the right crescent. Add up those three values. If you have set up a nice Venn diagram, then you can add those together, okay? Another way you can do an OR problem is to add up one circle and then the other circle, but then you counted the overlap twice, so subtract out the overlap. Okay, so either way, whatever you like to use to find the probability of S or C, okay, or whatever two events, one or the other, or both, of course, you can use a Venn diagram in either of those ways, okay? But on your formula sheet, there is a formula sheet for the AP exam. There will be this formula right here, so I want you to at least know where it comes from, okay? I think they use A's and B's instead of S's and C's, okay? Another problem here says find the probability that a randomly selected senior is enrolled in neither AP Stats nor AP Calc. Okay, so that means neither. And if you remember, that was the part that we calculated on the outside. Okay, almost like the complement of the problem we just did. And that probability of everything on the outside was 49 out of 96. And the symbol for that would be the probability of not stats and not calculus. Okay? Now, I know what all of that is, a lot of symbols, a lot of vocabulary. That's why I'm doing a video, so if you need to go back and rewatch this, maybe push pause, make sure you're digesting it. We will practice, of course. I might do one question here just to show you an example real fast, but we'll practice them in class so you can ask. But it does take a little bit of time for this to soak in. I know I promised this a short video, but I'm going to do one example really quick, and then we'll definitely do some more examples in class, okay? All right, this example was taken among a group of people. The probability that a person has a landline, so it tells us that that's going to be event A, is 93%. Cell phone is event B, and that's 71%. And then both is 66%. Okay, so this is a classic Venn diagram problem. If you get a multiple choice or a free response where they're basically saying, hey, here's one event, here's the other, and then here's both, you're thinking, Venn diagram. Let's set it up. So let a circle be A, an overlapping circle, these are not disjoint events because there's a both, be B. Now remember, I told you start in the middle. Now they already gave us these in decimals, so we don't have to really worry about fractions. So it could be fractions or decimals or even numbers is fine too. It doesn't have to be probabilities. Oh, sorry. I don't know where I'm coming from. Okay, so remember we always start at the overlap, which is 66%. So the 66 goes there. Now the probability of A was 93. I've already got 66 of those, that 93% taken care of in the overlap. So we're going to do 93 minus 66, and 27% is going to go here. For the cell phone, event B is 71% given into the problem, but we've already taken care of 66% of that. So 71% minus 66% gives us 5%. If you add those up, 0.27 plus 0.66, 0.05, we don't get 100%, we actually get 98%, leaving 2% to be those people that have neither a landline or a cell phone. Okay, so answering the questions, once you have set up this, take the time to set up this Venn diagram, the questions will just kind of flow. We've just got to practice our notation here, okay? So, first question, find the probability if a person has a landline but not a cell phone. So let's write that in probability notation. So landline was event A, and then not a cell phone. So I'm going to say event B and then complement, not a cell phone. And that is going to be, so A but not B, which means this part right here, 27%. I already did the math. All we've got to do is locate where on the Venn diagram they want our answer to come from. Okay, so the next one is, what's the probability a person has at least one kind of phone? So that means that they have at least one, so they could have both. This is just a or problem. What's the probability they have a landline or a cell phone or both, right? At least one kind of phone. So what I would do, we talked about the two different ways to do an or problem. So I could do I'm just going to show you both ways. So I could just add up the 3 sections of the Venn diagram that I've already created. And I see that my answer is 98%. So 98% of people have at least one kind of phone. Or I could have taken the probability that they have a landline plus the probability that they have a cell phone and subtract out the overlap, and that would also give me 98%. So either way. Part D, a person has at most one type of phone. Okay, so thinking about that, at most one type of phone, looks like we got to think about this a little bit. That means that they either have a landline, right? A cell phone, or neither, right? Because at most means that they only have one or none, okay? So this is basically looking at this. They have a landline, right? They have a cell phone, not both, of course, or neither. So notice that that's basically everything except for the overlap. Remember that the overlap is A and B. So basically it looks like what we're finding is everything except that. So 1 minus that. 1 minus the overlap. That's probably the easiest way to write that in probability notation. Okay, you could write what I just shaded. So let me try that again to show you the long way. Maybe I'm digging a hole here, but I could say, okay, the probability that they have a landline, which is the probability of A, but not B. The probability they have just a cell phone, which is the probability of B and not A. And then the probability that they have neither, which is the probability of not A and not B. And that means you're adding up 0.27 plus 0.05 plus 0.02, which gives us 0.34 again. So not an easy one as far as probability notation there. And then this one's easy peasy. We just talked about this one. A person has neither type of phone. The answer to that is 0.02. That's the outside part of the Venn diagram that we found. And in probability notation, that would be not A and not B. Not a cell phone and not a landline. Okay, I'll stop it there. We'll pick up on this when I see you guys in class. And make sure you write down any questions, star any questions, so we can have a good discussion about this stuff in class. Thank you.